Hello viewers, today it's a continuation of Logarithm 2 and we have 5 logarithm questions before us. That's question number 1, evaluate log 64 to base 2 down to question number 3, and then we have question number 4, if log 243 to base x equals 5 over 2, find the value of x. And question 5, if log 0.125 to base 32 equals p, what is the value of p? So we'll be delving into these questions very quickly. And to solve these questions that I have here, we'll be using the definition of logarithm, which says if log a to base x equals b, then this x, which is the base, carrying b, x raised to power b, will be equals to a. And this is what we are going to use to solve this each of these 5 questions. So let's start immediately. So question number 1 says we should evaluate log 64 to base 2. In evaluating log 64 to base 2, we are going to introduce a variable. So we say let log 64 to base 2 to be equals x. So if log 64 to base 2 equals x, that implies that this 2, which is the base, just like we have it in this definition, this 2 will come to carry this x. 2 raised to power x must be equals to 64. And of course, 64 is a number that has relationship with this 2, which is the base. So it means that we can have it in this format. 2 raised to power x equals to 64 can be expressed as a number in base 2 raised to its particular power, and that power is going to be equals to 6. Why? Because 2 times 2 is 4, times 2 is 8, times 2 16, times 2 32, and times 2 64. So you see, 2 has to be multiplied by 6 times for us to get 64. That's why 64 is 2 raised to power 6. Now, if 2 raised to power x equals to 2 raised to power 6, of course, we can see that these two bases are exactly the same thing. So it means that they can cancel out. That implies that x will be equals to 6. So it means that when we evaluate log 64 to base 2, it's going to give us what? 6. So that is question number 1. So we go to number 2 very quickly. In a similar manner, we have log 81 to base 27 this time around. So we are going to let log 81 to base 27 to be any variable of our choice. This time around, we can let it to be equals to m, for example. So if log 81 to base 27 equals to m, what does that imply? It implies that 27 to power m must be equals to 81, still referring to the definition of logarithm. And of course, 27 also has relationship with a very simple number. And what is the simplest number that 27 has relationship with? That is 3. So it means that this 27 can be expressed as 3 to a specific power, and that's going to be 3. So 3 raised to power 3 is going to give us 27, because 3 times 3 is 9, and then times 3 is 27. So 3 raised to power 3 is 27. But then this 27 was initially raised to power m. So this is 3 raised to power 3, representing 27, and that 27 is not being raised to power m. Now that's equals to 81 also has relationship with 3, and that's going to be 3 raised to power 4. If you follow the steps and the procedure that I've been showing. Now 3 raised to power 3, then raised to power m equals to 3 raised to power 4. What does it tell us? It tells us that according to one of the rules of indices, this power 3 is going to multiply this power m. So we'll be left with 3 raised to power 3m, because 3 times m is 3m. And 3 raised to power 3m will be the same thing as 3 raised to power 4. And of course, as before, this base is 3 and this base is 3. So both can cancel out. So we'll be left with 3m equals to 4. That's by equating the powers. So if 3m is equals to 4, what does that tell us? It means that m will be equals to 4 over 3. Of course, when we divide both sides by 3 to make m to stand alone, 3m divided by 3 will give us m, and 4 divided by 3 will still give us what? 4 over 3. That's an improper fraction, or we could choose to write it as a proper fraction, or a mixed fraction. I mean, that's going to be one whole number 1 over 3. So either of these two solutions is the value of log 81 to the base 27. So we'll proceed to question number 3 very quickly. So here we go. We want to evaluate log 128 to base 0.25. And to evaluate this, we are going to let log 128 to be 0.25 to be any variable like we've been having it. Now, if it is equals to y, it means that 0.25 to power y must be equals to 128. Alright, so this is a bit different from the first two that we did, but they are actually exactly the same thing. So what do we do to bring them to the same, to look alike? We are going to express this decimal as a fraction. It's a decimal fraction, so we want to express it as an exact fraction. So in expressing 0.25 as an exact fraction, you know that that's going to be equals to 25 over 100 by your idea of changing decimals to fraction. So 5 here is going to be 5, 5 in 100 is going to be 20, 5 in 5 is going to be 1, and 5 in 20 is going to be 4. So 0.25 when expressed as a fraction in the simplest form is going to give us 1 over 4. And of course, this 1 over 4 is going to be raised to power y. That is what we have in the place of 0.25. And that's going to be equal to 128, because we have just simplified 0.25. Then this 1 over 4 also can be expressed in a simpler base of 2. And that's going to be 1 over 2 raised to power 2, because 2 raised to power 2 is actually equals to 4. And this will be raised to power y. So that's going to be equals to 128 as a base, or the simplest base it can take is 2. And of course, 128 is equals to 2 raised to power 7. You can confirm that. Now, by one of the laws of indices, when we have 1 over 2 raised to power 2, so this 1 over 2 raised to power 2 can be expressed as 2 raised to power negative 2 as a negative power. So we call it the negative power law of indices. So 2 raised to power negative 2 then will now be raised to power y. That's going to be equals to 2 raised to power 7. And of course, as we had it in question number 2, negative 2 is going to multiply y, because this 2 raised to power minus 2 and then raised to power y. Negative 2 multiplied by y is going to give us 2 raised to power negative 2y. And that's going to be equals to 2 raised to power 7. So if 2 raised to power minus 2y equals to 2 raised to power 7, of course, again, we can see that the bases are exactly the same thing, so they can cancel out. It means that negative 2y will be equals to 7. So if negative 2y is equals to 7, as before, we are going to divide both sides by negative 2 so that y can stand alone. And when we have that, we are going to have y equals to 7 over negative 2, because negative 2y divided by negative 2 is going to be only y. 7 divided by negative 2 is going to give us this. So our solution is either 7 over negative 2, if we like, or negative 3 whole number, because 2 can go in 7 3 times. So negative 3 whole number 1 over 2. So either of these two solutions again is the value when we evaluate log 128 to base 0.25. These two values are what we have. Thank you. So we move on to number 4. So question 4 says if log 243 to base x equals 5 over 2, find x. Log 243 to base x equals 5 over 2. So we are looking for the value of x, and still on the definition of logarithm. So what are we going to have? It means that this x to power 5 over 2 must be equals to 243. So if x is raised to power what? 5 over 2, it must be equals to what? 243. So what do we do in this situation? Okay, so when we have this, our target is to find the value of x. Now, how do we get the value of x? X is having a power of 5 over 2. Then we want to take away this power 5 over 2, so that we'll be having what's just a power of 1. Because of course, when x has a power of 1, x raised to power 1 is just the same thing as what? Ordinary x. And if we are able to achieve this, it means that we have been able to what? Achieve our goal. That is what we are looking for. So how do we achieve this? So we focus our attention on what? The power of x. What is the power of x? It is 5 over 2. And now 243 is not having any power. If it is not having any power, it is assumed to carry the power 1, because any number raised to power 1 remains itself. So 243 raised to power 1 is the same thing as 243 unchanged. So how do we achieve making the power of x to be equal to 1? This is what we are going to do. We are going to say x raised to power 5 over 2. 5 over 2 is the power of x. So we are going to look for the reciprocal of 5 over 2. What do I mean by reciprocal of 5 over 2? You switch 5 over 2 upside down. When you switch it upside down, it becomes 2 over 5. So that reciprocal, you are going to multiply it by this 5 over 2. So 5 over 2 multiplied by 2 over 5. That is what we do. And when you do it to the left hand side of this equation, of course, you have to do the same thing to the right hand side of the equation. So it becomes 243 also raised to power 1 as it was, now to be multiplied by 2 over 5. Because it is 2 over 5 that we use to multiply the power of this, so we use the same 2 over 5 to multiply the power of this. So what happens? This is now going to become x raised to power 5 times 2 is 10 over 2 times 5 is also 10. So you can see what we are coming up to. So this becomes 1 multiplied by 2 over 5. That's 243 raised to power 2 over 5. Because 1 times 2 over 5 is 2 over 5. And of course here, 10 divided by 10 is 1. So what happens? Will be left with what? X raised to power 1, which is what we are setting out to achieve. And that becomes, this is 243 raised to power 2 over 5. There are two ways to solving this. If you like, you can use the laws of indices that say you are going to look for the fifth root of 243. So this 5, which is under here, comes to the back. And then we are going to raise it to what power? Power 2, which is on top. So x raised to power 1 is just what? X. Now, what is the fifth root of 243? Like, what number will you multiply by itself 5 times to give you 243? That's what they mean by fifth root of 243. And of course, it is 3. Because 3 times 3 is 9. Times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. So the fifth root of 243 is actually 3. And this 3, you haven't gotten it. You are going to raise it to what power again? You are going to raise it to what? To power 2. It tells us that x is going to be equal to what? 9 as the solution. That tells us that when you have 243, log 243 to base 9 is the one that is going to give you what? 5 over 2, which makes the value of x to be equal to 9. That's question number 4. And to the final question, which is question number 5, we move. If log 0.125 to base 32 equals p, what is the value of p? So let's try the silence teaching. So either negative 3 over 5 or negative 0.6 is a solution to this. 32 raised to power minus 3 over 5, 32 raised to power minus 0.6 is going to give us 0.125. So ladies and gentlemen, I give you the 5 questions to logarithm and the 5 solution using the definition of logarithm. If log a to base x equals b, then x raised to power b equals a. Thank you.